Okay, News. Now let's see an example on where we are going to use these formulas, and we are going to use it on this kind of Laplace inverse. Now, uh, uh, the power of the denominator is second power, so that means it's going to have two roots, and, uh, and the common action will be to get the partial fractions. However, that is not true because what are the roots of this? Now, if the root of this polynomial is real, then we can do partial fractions. But if they are not real, if they are imaginary roots, then we cannot make partial fractions. Okay, so let's do the chicharronera, all right? So S1 and 2 is equal to minus 2 plus minus the square root of 4 minus 4, 1 and 5 divided by 2. So S1 and 2 is equal to minus 2 plus minus the square root of 20, 4 minus 20 minus 16 over 2. And here I can see it is not real because the square root of the negative. So the square root of 16 is 4. 4 divided by 2 is going to be 2. So it's going to be minus 1 from here and then plus minus 2i. So that are the roots. So they are not real, therefore we cannot do partial fractions. Okay, so what should we do, engineers? We don't have a formula for this that fits in this. Okay, so what we have to do is this. Before you try to apply any formulas, let's do this. This is the procedure. 8s minus 7 over s squared plus 2s plus 5. I'm going to, yes, minus 7. Check that I have give some space here, 2s, between the 2s and the 5. Now, this procedure is called to complete the binomio, completar el binomio in Spanish. Now, to complete the binomio is like this. Half of this number, 2 divided by 2 is 1, the square of that number is 1. So what we are going to do is to add plus 1, and because we cannot change that arbitrarily, then we have to do minus 1 to compensate. Okay, so what is the result of this? 8s minus 7 over s squared plus 2s plus 1 plus 4. Alright, now take a look to this. Why we do this? Complete the binomial. Because this is a binomial. Okay, because that is a binomial, then we can write it like this. 8s minus 7 divided by s plus 1 s squared plus 4. I'm going to write that 4 as 2 squared. Alright. Now, have you seen that denominator before? Well, this denominator, you can check it, is very similar to the formulas of the exponential and cosine, and the exponential and the sine is the same denominator. S minus or plus something squared, and then the k squared. Okay, now, so we have the same denominator as these formulas, but we don't have the same numerator. In the numerator, check for the cosine. This number and this number, they should be the same. And for this formula, you should only have a number, which is not the case. 8s minus 7. Okay, so we have to do the following, engineers. Check that I give some space here because I'm going to complete. What I'm going to do is here, s minus a and s minus a squared here. So what we have to do here is s plus 1 in order to apply this formula. Alright? The same number in the numerator and the denominator, just like in the formula. But we have to compensate. Okay, so we have s plus 1 and then minus 8 to compensate. Why it is not minus 1? It is not minus 1 because this is going to be multiplied times the 8. 8 plus times 1 is going to be 8. Then the compensation will be minus 8. Alright, so what we have is the following. 8s plus 1 over s plus 1 squared plus 2 squared, and then Minus 7 and plus 8 is going to be minus 15. Okay, now we have this with the same shift, alright, and we have the number just like here. So we are going to split the fraction, this fraction into fractions like this. 8 times s plus 1 over here, 8 times s plus 1 squared plus 2 squared, and that is for this. And then the next one is for this, minus 15, and then 1 over s plus 1 squared plus 2 squared. Okay, so now check. Do we have the same shape as in the formulas? Yes, for this is s plus 1, well here s minus a and s minus a. There is no problem here with the positive. You can write like this, minus 1, and here minus 1, which makes it positive. So the value of a happens to be minus 1, and the value of k happens to be 2. So for this number, it's going to be, if we apply the Laplace inverse, which is what they are asking, the Laplace inverse, if we apply the Laplace inverse of all these, then what we are going to have, if we apply this formula, the value of a happens to be minus 1, and the value of k happens to be 2. So the Laplace inverse of this is going to be 8 exponential of minus t cosine of 2t. And then the Laplace inverse of this. Now be careful here because it's not the shape of the formula. It is for the sign, but what you have to have here is k, and here k squared. So the value of k, here a happens to be minus 1, and the k happens to be 2. Okay, but we don't have 2 in the numerator, just like in the formula. So what we have to do is to multiply here 2 and then divide by 2 to complete the formula. It's very similar to the integrals where you have to complete the integral. You have to compensate the formulas. Okay, now that we have k and below k squared, now we can apply the formula. It's going to be minus 15 over 2 exponential minus t, the sine of 2t. And this is the way to work on this kind of fractions where you have to complete the binomial. I'm going to make here the note, complete the binomial. And the reason behind completing the binomial is that to have the same denominator as the formulas here. Alright, so these are the examples where you are going to use this kind of formulas. Alright, you are going to use this method, this technique, so please pay attention on this procedure. Not all the problems will be the same. Maybe here is another number, so you have to make another to complete in a different way. And pay attention here. You have to do this whenever you have this kind of fraction and it is imaginary roots. Otherwise you cannot use it. Alright? Okay, let's solve a problem from the homework where you are going to use these fractions. Alright?